Good morning. Uh, Today I am going to teach about uh, a geometric figure called parabola. So, what is a parabola? First, we define something called conic section. So, if a point moves in a plane in such a way that its distance from a fixed point uh, and its distance from a fixed line has a constant ratio, then the locus of the point, locus of the moving point is called a conic section or simply a conic. So in this picture you see, uh, if the point P moves in such a way such that its distance from a fixed point S and the distance from the fixed line, which is mx, so the ratio of sp and pm is constant. So if it is constant, then the locus, that is the curve we see here, is a conic section. So uh, sp by pm is called the eccentricity of the conic section, and it is denoted by the letter e. So now this is a conic section. So parabola is also a conic section, but in the case of parabola, this e is equal to 1. So that means the sp is equal to pm. So sp is equal to pm means the point p moves in such a way, um, such that it traces the equal distance from the fixed point and the fixed line. So the fixed point is called fixed point S, which is S here. That is called the focus of the parabola, and the fixed line is called the directrix. So now we find the equation of the parabola. So this is a parabola. So now we will describe how we can find the equation of the parabola. So um, here P in the picture, P is the locus of the point, S is the focus, and MZ is the directrix line. So first we are given a point S and a line MZ. So now, and we have to find the locus of a point P, which moves and also keeps fixed distance from the point S as well as the line MZ. So what we do now, we have to define a coordinate system first. So how we can do that? We can uh, what we can do is, we can um, draw a perpendicular line from S to the given line MZ. So we call that SZ. So SZ is, first we define SZ. So suppose SZ is of some distance x. So and suppose SZ is bisected at the point A. In the picture you see A. So we define that A to be the origin. So the what is the coordinate of the point? 0 0. So now that is the origin, and uh, since it is bisected, sub as is equal to az. So as we define, if the distance as is a, and we define this line JAS, and extending it, we define it to be the x-axis. So the coordinate of the point S becomes a comma 0, and the coordinate of the point Z becomes minus a comma 0. And now we define the line perpendicular to this line JAS, and passing through the point A, that is the line AY, to be the y-axis. So now we got our coordinate system, and now we will find the locus of the point P. So suppose the coordinate of the point P is xy. So now by the definition of parabola, this point P has equal distance from the point S and as well as the line MZ. So first, the distance of the point P and distance between the point P and S is given by um, root over x minus a whole square plus y square, and the distance between the line and the point P is given by x plus a. So root over x minus a whole square plus y square is equal to x plus a, and squaring that, and we get that y square is equal to 4x. So this is the equation of the parabola. So now we solve a simple problem. So we have to find the vertex, focus, lateral rectum, axis and directrix of the parabola. 3y square is equal to 4x. So we can write this equation as y square is equal to 4 by 3x. So this is of the form y square is equal to 4ax, as we have seen the equation of the parabola. So comparing, we can get 4a is equal to 4 by 3. So what is a? A is 1 by 3. So uh, uh, from the form of this parabola y square is equal to 4x, we know the vertex is always of the coordinate 0 0, and we know the focus is, if a parabola has equation y square is equal to 4x, its focus is a comma 0. So what is a here? A is 1 by 3, so the coordinate of the focus is 1 by 3 comma 0, and the lattice rectum is the 4a. So it is 4 by 3, and axis is the y axis, that is sorry, x axis. So it is y is equal to 0, and equation of the directrix is given by x plus a is equal to 0. So it is x plus 1 by 3 is equal to 0. So now we find some other forms of parabola. Other forms of parabola means the geometric shape will be different. So suppose the parabola is curved concave uh, around the negative x-axis. So in that case, the focus coordinate of the focus is minus a comma 0. The vertex is 0 comma 0, and the axis is the negative x-axis. So the equation of the parabola will be y square is equal to minus 4x, and here a will be greater than 0. Also there are other forms of parabola like these two, as you see in the picture. Here the concavity is around the positive y-axis in the first picture, and the second picture the concavity is around the negative y-axis. So in this case, the equation of the parabola will be given by the first case it will be given by x square is equal to 4ay, a greater than 0, and the focus in this case will be 0 comma a. Instead of before we saw it to be a comma 0, but here it will be 0 comma a, and the concavity will be upwards. And in the second case, the equation of the parabola will be x square is equal to minus 4ay and a greater than 0, and focus will be at 0 comma minus a and concavity downwards. And if we take the directrix line to be the x or y axis, then the equation of the parabola becomes y square is equal to 4a into x minus a. This is also an interesting point to note. And so now we find the general equation of the parabola. So general equation, in the general equation of the parabola, we are given a point S, which is the focus point, and the coordinate is p comma q. Suppose the coordinate is p comma q, and another line we are given, that is the directrix line. And suppose the equation of the directrix line is lx plus my plus n is equal to 0. So if by the definition of the parabola, parabola is the locus of the point P, which moves in a fixed distance from the point P and focus point and the directrix line. So if xy is the coordinate of the point, then the distance between the point xy and pq is root over x minus p whole square plus y minus q whole square, and the equation of the directrix line is and the distance between the directrix line and the point P is Lx plus My plus N by root L square plus M square. So squaring these two and equating, we get the equation of the parabola of the form Ax plus By whole square plus 2gx plus 2Fy plus C equal to 0, where ABC will be some constant depending upon the P, Q, L, M, N, these things. So finally we solved a problem. So what is the equation of the parabola? whose focus is the origin, and directrix is the 2x straight line 2x plus y is equal to 1. So if xy is a point on the parabola, then distance from the origin of distance from the focus, that is the origin, from the origin is root over x square plus y square, and distance from the line 2x plus y minus 1 is equal to 0 is equal to 2x plus y minus 1 by root over 2 square plus 1 square. So now equating these two and squaring, we get 2x plus y minus 1 whole square is equal to x square plus y square. So the equation of the parabola will be x square plus 4y square minus 4xy plus 4x plus 2y minus 1 is equal to 0. So in this way, we study the parabola and we can solve many other problems.